My name is Javier Hernandez and my nickname is Chicharito.
What is up, guys? This is Luke Hill for Kikaroo, and it's been pretty hot in the UK recently, where basically nobody has air conditioning inside their home or their home office. So that got us thinking about how to cool the hardware adequately. And it was at that point we remembered actually we got a Cooler Master cooler that was sampled quite a while back, and now seemed like a good time to test it. So the Cooler Master Master Liquid ML360 Sub-Zero uses TEC, so Thermoelectric cooling hardware, and Intel's Cryo cooling technology software to cool your CPU down to sub-ambient levels as low as 0 degrees Celsius on the sensor reading. Now there are some limitations with regards to power draw, but sub-ambient cooling in a pretty neat package, that seems like something pretty interesting to test. Fundamentally, this is intended for use with smart overclocking utilities such as Intel's thermal velocity boost algorithm, and the methodology there is that you boost up a few of the cores to ludicrous numbers like 5.5 gigahertz if you can, and then when you're under a heavy all-core load, you go to something a bit more sensible. Now, if you're like me and you think, well, in theory, that sounds like it could be pretty good for precision boost 2 on AMD Zen processors, then yeah, it probably would be, but you don't get AMD support. LGA 1200 is required, so a 10th or 11th gen CPU is what you'll have to use. Anyway, like I said, hot summertime here in the UK. The ambient condition in my room right now is about 27 degrees Celsius and often is up towards 30 degrees, so this seems like a pretty perfect time to test some sub-ambient cooling. Let's have a look at this 340-pound CPU cooler. Before we do that though, if you like what we do here at Kikaroo, make sure you give us a like and subscribe. You can stay in tune with us there, and you can check out the Kikaroo website. And also something new that we've got is you can join the Kikaroo page on YouTube as a member. Really cool features there. You can help us get to our next milestone as well. Let's get back into it. The key feature of the Cooler Master ML360 Sub-Zero is the TEC, so Thermoelectric cooling hardware, or Peltier if you prefer. Put simply, this hardware mounted inside the massive CPU block takes a 6+2 pin PCIe power connector to deliver electrical current to the TEC. It then takes that electrical power and fundamentally just converts it into cooling capacity in a pretty nifty Peltier process. The key point is that electrical power is being input into the cooling system to allow for the removal of thermal energy from a heat-producing source such as a CPU. Of course, this is a stark contrast to standard air or AIO coolers where sub-ambient conditions are just physically impossible. And the electrical power put into the system to run the TEC is basically cooled by the radiator and the fans, as well as any excess CPU power that the TEC cannot handle. So this 360 rad is doing quite a bit of work. There's more information on TEC technology and how it uses the Peltier process online. That's pretty dense material, so certainly not relevant for this review, but if you are interested, make sure you search for it. According to the Cooler Master webpage, the total power rating for the CPU cooler is 200 watts. That's right, the CPU cooler draws 200 watts maximum. 200 watts for the cooler, the actual cooler. Basically what that tells us is that somewhere up to about 200 watts is going to be the limit for the TEC cooling capability, because realistically you're not going to be able to push any more through there without then dumping that heat to the radiator and saturating it quite quickly. And this 200 watts power requirement for the CPU cooler also emphasizes the requirement for a 6+2 pin PCIe power connector, as well as a beefy, efficient power supply. Inside the block unit, which houses the TEC, are sensors. These sensors read atmospheric data such as temperature and humidity, and they can therefore calculate the dew point. This information on dew point allows the CPU cooler to operate in its cryo mode without having to worry about condensation around the CPU socket. Aiding this condensation concern further is a seal around the CPU socket, so below the base of the CPU cooler, that is intended to prevent warm air from getting close to the CPU socket, especially in sub-ambient conditions, so you're not really going to have the likelihood of air condensing or liquid condensing there and causing basically short-in problems with liquid on your motherboard. Of course, if you're a bit less risk averse and you just want all-out maximum cooling, you can rely upon the seal that Cooler Master has created, the rubber gasket effectively, and you can run in the unregulated mode, and this basically targets maximum cooling performance, runs the CPU cooler with a boatload of power, but it can get sub-ambient. We did see 0 degrees Celsius, so you can go for that mode if you really want to. Just watch out for condensation. The pump is an inline unit which is pretty big and far heftier than what we typically see from a conventional all-in-one liquid cooler. In our testing, it ran at about 5700 or 5800 RPM, so certainly very high speed for an all-in-one pump. It's powered via a proprietary connector that is connected to the breakout cable that Cooler Master supplies. And you get a mounting bracket to fit a 120mm fan slot, but this is pretty annoying because we actually use 140mm fans in the front of our CPU cooler test chassis, so we have to actually remove one of those 140mm fans and use the case's 120mm mounts because there's no 140 mount on the pump. And then of course I'm just going to put the usual disclaimer at this point saying that you should mount the pump lower down in the system so that it never will run dry. Just good housekeeping for liquid cooling there. And clearly there's plenty of inflexibility and tension on these cables once they are installed in the chassis, but I guess that's the way that it goes, and at least they look good with their braided appearance. The 360mm aluminium radiator is very much conventional, nothing fancy there, and pre-installed are 3x120mm SF120R fans, and these are rated up to 1900 RPM full speed. They use a 4-pin connector, and they also connect to the SATA-powered breakout cable that also runs the pump unit. The fans are black and they have no RGB lighting. Now, you can sound off in the comment section if you think a lack of RGB is a problem in today's market, or if you actually appreciate no RGB in a system like this. And then I guess some other points I should say with regards to the fans is obviously you can use this USB cable for control through your system, which is particularly short. I'm not sure why Cooler Master went with such a short USB cable. Fine in our case, might not be in your case. But you also get limited speed control functionality with the Intel Cryo cooling software technology. So just bear that in mind. With regards to support and compatibility, you do need to be running the Intel Cryo cooling software, which you can download via a link on the Cooler Master website. You'll want a BIOS update if you're running an older Z490 motherboard, and you'll probably want to run Intel XTU as well, just for general system performance and maintenance. Cryo software only actually works with 10th gen and 11th gen K and KF processors, so according to the webpage at least, no older high-end desktop support, no current high-end desktop support, and no older chip support if you've got a, I don't know, a 6700K that you want to mess around with. Unlucky, I guess. Clearly, no AMD support, and there's no actual mounting hardware for AMD either, because this is LGA 1200 only. Pretty disappointing given that fundamentally this is a Cooler Master cooler, not an Intel cooler, although the Cooler Master X Intel on the side of the packaging would imply that they've worked, pretty close together. Anyway, I think that covers the overview of the Cooler Master ML360 Sub-Zero. Let's get into the testing phase and have a look at our test system. Our usual CPU cooler test system is based around the AMD Ryzen 9 5950X, but clearly that's not possible with this cooler. So we switched to the Intel platform instead. As such, we're running the ML360 Sub-Zero with our favorite 10th or 11th gen processor, and that's the Core i9 10900K. Yes, we could have used the 11900K, but we actually think the 10900K is just better, and it can push more power if you really push the CPU hard. The motherboard is an MSI MEG Z490 ACE. We're using a 16GB kit of KLEVV 4GHz DDR4 memory. The graphics card is a Gigabyte RTX 2060 Super. And in terms of power supply, that's actually particularly important here, given the strenuous demands from the CPU cooler as well as the rest of the system. So we're using a Seasonic Prime TX1000, and that's 80 plus titanium, 1 kilowatt, very efficient, very sturdy. And of course, our go-to CPU cooling chassis is the Fractal Meshify 2. And this handles the 360mm all-in-one as well as the inline pump without any hassle whatsoever, once you remove that front fan, of course. Typically, this is the point where we would outline some of the test procedures that we're using, some of the comparison coolers for the barrage of tests that we do, and highlight how they were run. However, this is such a unique, different cooler that we can't really do that here. And because of the intended use case of lightly threaded, even single-threaded, heavy overclocks under thermal velocity boost overclocking type situations, we're basically going to go through some hands-on testing rather than data and charts on screen, so you can see our actual usage running this CPU cooler. Here we can see the system has been running around about 25 minutes, or just under 25 minutes of Cinebench R23 on loop. We have the cooler in its cryo mode, so not the extreme mode, but the cryo mode. And we've actually tried the unregulated mode, but it doesn't make a difference because the cooler, the TEC, is actually working at full power right now. And what we can see is the system is quite stable in terms of temperature. So right now we're at about 50 degrees package temperature, and our package power is somewhere in the order of about 125 watts because we have the Intel standard, not the motherboard vendor crazy mode applied. And we can see the temperature is typically in the order of about high 40s. Realistically, it's been hovering around about 50 degrees Celsius for quite a while, but you're getting pretty good stability in sub 50 degrees for 125 watts package power. And of course, this is an all-core load, 4.2 gigahertz on our 10900K. After running this for about 20 minutes in the cryo mode, if I go in and switch to the unregulated mode, you'll basically see that there's realistically no difference, and that is because the power of the TEC is maxed out in the cryo mode anyway. And if I just hold up the wall power draw, we can see 353 watts of wall power draw, which is absolutely insane. So we're running the unregulated mode right now, and it's made basically no difference. But what I will do right now is switch from the unregulated mode, and I'm going to drop down to the standby mode, which is turning off basically the extreme cooling units, and we'll watch the power drop instantly. And there you go, we've dropped about 170 watts off the wall power draw. And then we'll have a look at the temperatures. And we can see the temperatures are already starting to spike up quite heavily. So we're already at high 60s on the package temperature, and this is still only 125 watts TDP. We're over 70 degrees now, so really not very good cooling with that TEC unit turned off. After subjecting the unit to its standby mode under a heavy load, we can see that that's really not what this cooler is designed for. So if I switch back to the cryo mode, we'll have a look at how quickly the temperatures can come down. And this time I'm just going to jump into HW info, and we'll keep an eye on the temperature falling, and we can see it's already from low 80s down to low 70s right now, and we can see it's dropping even further. If we have a look at our package power draw, our wall power draw, again 360 watts from the wall, so the unit is at basically max power, and it is pulling that CPU temperature down. We're already hovering around the 60 degrees Celsius mark, so it does pull it down quite quickly indeed. Of course, it takes a ton of power in the process though. We've just removed the load from Cinebench R23. We're still in the cryo mode, so not the unregulated mode, and already we can see that our CPU temperature is down sub-ambient, so about 15 degrees Celsius package power according to XTU. The CPU is not actually doing much. If we have a look at the wall power draw, that's about 100 watts. And then we can click in the little utility to see how much power the actual cooler is drawing. It's drawing about 28 watts. So it's really not doing all that much to get sub-ambient in our roughly 25 degree room at the moment. If I switch up to the unregulated mode, then we'll see a massive spike in power draw, and I'll show you that on the power meter. And already we've added about 150 watts worth of power draw. And then if I pull the meter out of the way, we should see that package temperature tending pretty quickly towards 0 degrees Celsius. And there we go, 0 degrees Celsius. Freezing point of water using the Cooler Master Sub-Zero liquid cooler. Pretty insane to see indeed. And the power, about 220 watts from the wall, when realistically we should be idling at about 80 watts. Pretty insane indeed. So that 125 watt testing is okay, I guess. Sub 50 degrees Celsius for a 10900K is not bad, but it is only 125 watts after all. Then again, 0 degrees Celsius under idle conditions is pretty cool to see. But let's turn up the workload. We're going to boot up the system with the Cooler Master Sub-Zero cooler, and we're going to see how it handles the pretty aggressive motherboard vendor crazy stock mode, shall we say. So obviously not the typical Intel 125 watt TDP, but stock with XMP enabled, but with the water cooler setting in our MSI UEFI, which allows the TDP to go crazy. Let's have a look how this cooler handles that. We have the system launched up currently, and this is using our stock settings, but with the motherboard vendor crazy mode applied, so the aggressive stock, shall we call it. The CPU cooler's in standby mode right now, so I'm just going to apply the cryo mode initially. And the Cooler Master does say that you can use this cryo mode all of the time. You don't have to worry about condensation like with the unregulated mode. So we'll just give it a second to do its business. We can already see that we're basically, well, we are now sub-ambient according to XTU. Let's launch back into XTU. We'll have a look at this curve to see how the CPU package temperature tends. So already we can see the package TDP is around about 210 watts. So this really is pushing the limit and is probably further than you should be taking this cooler. But we'll run it for a few minutes and see how it fares. Obviously, if the temperature goes too high, we'll just cancel the test and look at something more appropriate for this level of cooling. What we can see at this point is the CPU package power is 220 watts going to XTU. The ancillary components probably take that up to about 300 watts. But altogether, we're talking about 475 watts from the wall. So the cooler itself is using an absolute boatload of electricity to try and maintain the heat down on our 10900K. And according to the utility, it's running about 163 watts right now. So yeah, it really is being pushed incredibly hard indeed. And already we can see the package temperature is bordering on 90 degrees Celsius for a motherboard vendor aggressive stock 10900K, so 4.9 gigahertz. That is very unimpressive. We're actually going to get towards 99 degrees and fail in a second, so maybe we'll give it a little bit longer just to see us get into 99 degrees. But yeah, I'm going to cancel this because we can already see we're red and we are thermal throttling. Unimpressive. That's after 1.5 minutes. Stock multi-core turbo performance is very unimpressive as the cooler lets the CPU spiral to its 99 degrees Celsius thermal throttling point within about 1.5 minutes worth of Cinebench. Put simply, a 10-core chip such as the 10900K demands too much from the CPU cooler and the TEC just can't keep up. By comparison, a 360mm all-in-one liquid cooler with the same workload was happily able to achieve sub 75 degrees Celsius for a 30-minute Cinebench run at the same settings. So that is quite the stomping for a 360mm Ace versus this Cryo technology cooler. Well, I guess we've already confirmed pretty quickly that heavy CPU loads under elevated clock speeds are just not the domain of the ML360 Sub-Zero. So I guess we should now take a look at thermal velocity boost overclocking with lighter core count and lighter threaded workloads. Let's get into that. We're back in XTU now. We've concluded that the system doesn't really like anything above about 5.7 gigahertz, so every time we've tried that, the system has just crashed, even in XTU, just trying to save the settings. So let's see if we can get 56 before calling it a day. Here we can see the system running Cinebench 1T, and we are seeing signs of boosting up to 5.6 gigahertz on the cores. So 10900K running at 5.6 gigahertz, even if the voltage is pretty high, it is single threaded, so whatever. The package power is fine. The temperature is absolutely fine because we're running the TEC, so the Cooler Master Sub-Zero, in unregulated mode, so it's drawing a boatload of power from the wall. 290 watts for a 65 watt package power is absolutely insane. But there's something cool about seeing 5.6 gigahertz on an Intel chip. Now the performance is not there to justify this expense or this whole palaver, quite frankly, because you can get more performance from Zen 3 on single-threaded Cinebench, for example. But if you have a particular use case that needs the highest Intel single-threaded or lightly threaded performance, maybe this is a cool solution if you have questionable sense of value and very, very deep pockets. Okay, so with some XTU tweaking under lightly threaded workloads and keeping the CPU power under 125 watts long duration, you can indeed get some crazy temperatures and crazy clock speeds. It's not all that useful in the real world, to be quite frank, but it is cool to see those lofty numbers on the frequency side of things. Of course, that's using the unregulated mode, which absolutely guzzles power, so let's see how the more sensible Cryo mode does. Now we've got the system running with the Cryo mode, so sensible, cooler power draw. We're on about 100 watts from the wall, maybe a bit more when idling, and the cooler is reporting as about 30 watts worth of power to keep at this sub-ambient temperature, but basically the sensible mode. So let's run a single core test and see how we fare. And we'll just load back up our monitoring data and see if we can indeed hit, this time, 5.5 is our target, because it doesn't seem to like 5.6 under this Cryo mode with sensible cooling. And we are seeing signs of 5.5 being hit. Perhaps not glued there because we have changed some of the XTU settings, just to be a bit more sensible with the Cryo mode as opposed to the unregulated mode. But we are seeing signs of 5.5 being hit. Power is once again about 60 watts for the package, and this time we're about 40 degrees Celsius, so absolutely fine, but not crazy. And if we have a look at the cooler power draw, somewhere in the order of 46 watts or to 66 watts now according to the software. And then if we have a look at the wall power draw, we're talking about 185 watts. So far lower power draw than the crazy unregulated mode. Still perfectly fine for the cooling, and we are seeing signs of hitting our really high boost frequency. We're not glued to the high boost frequency, but we are seeing signs of hitting it. So perhaps a far smarter mode if you do actually care about power consumption, longevity, and not just blasting energy through your cooler from the TEC, as opposed to actually just cooling the CPU sensibly. For reference, the 360mm ACE all-in-one was around about mid-50s for the Cinebench 1T run at 5.4 GHz manual OC, and that was about 70 watts worth of package power. So the actual temps of the ML360 Sub-Zero in Cryo mode are really quite good, to be fair. Clearly a target such as 5.5 GHz and running the cooler in Cryo mode are far more sensible for the temperatures and also the power draw from the cooler itself. So now, let's try some games. We've got F1 2020 running. What we can see under this 5.2 GHz testing is that we've got headroom because we're only drawing about 80 watts from the package and the CPU temperature is absolutely fine. So let's jump into XTU. Let's bump it up to 5.3, a nice and safe 5.3, see if that works. Let's load our monitoring tools back up. Jump back into F1 and see if we can indeed get 5.3. And there we go, we're glued at about 5.3 GHz. Let's try 5.5. This could end badly. Okay, that's positive so far. Let's run into our game. What do you know? 5.5, working in game. We're in Rocket League and we're currently running at a crazy 660 FPS. And in fact, we're now pushing 5.5 GHz on all cores. Now, of course, this is not a particularly heavy load, but the package power is still below that 125 watt. I don't want to call it a sweet spot, but the point where the cooler starts to show some limitations with a heavy multi-threaded workload. So yeah, if you want 5.5 GHz gaming, this looks to be an option. The package temperature is around about 60 degrees Celsius. The wall power draw is going to be astronomical with our 3080 at full power, 650 watts. Oh my word. And about 150 of that is going to the CPU cooler, according to the software. That is crazy. However, 5.5 GHz gaming, well, this is it. Is it pointless? Well, if you want over 700 FPS, I guess not. Looking at noise output, the cooler is undeniably loud when pushing the temperatures down low. The fans are not particularly quiet, and there is also a noticeable hum from the pump with limited speed control through the Intel Cryo technology software. So yeah, I'd say noise output is not ideal. I think that's enough time messing with the Cooler Master ML360 Sub-Zero and messing around with the different modes and testing the different conditions. We've got a pretty good picture of how the CPU cooler is at this point. To summarize, the cooling performance is actually very good for lightly threaded workloads on hefty overclocks for K-series processors. Now, K-series processors with hefty overclocks and lightly threaded workloads, clearly that's an oxymoron. However, we did see sub-ambient temperatures running the sensible cryo mode for cooling, and we did get 0 degrees Celsius on the sensor reading when running the crazy unregulated mode. So the cooling potential is there, provided you don't oversaturate the TEC. Of course, the challenge is, as soon as you hit it with a pretty heavy multi-threaded load for even a reasonable processor these days, so something in the order of about 200 watts, you really are going to overpower the TEC and the temperatures basically go through the roof and the performance falls off a cliff. It's actually unstable, which is pretty remarkable for a 340-pound cooler to be unstable out of the box with typical stock multi-core turbo motherboard settings for a 10900K. That's pretty bad, but again, that's because of the unique performance that this cooler is designed for. If we just compare that stock multi-core turbo point to something like a 360mm ACE cooler, whereas the Cooler Master unit just couldn't handle the workload of 200 to 220 watts, that 360mm ACE cooler will run about sub 75 degrees Celsius in our testing, and that's on a 30-minute Cinebench run. So clearly a massive difference there for actual real hefty workloads with hefty power consumption. That's not the use case for the ML360 Sub-Zero, clearly. Put simply, the ML360 Sub-Zero is a pretty weird toy created by Cooler Master and Intel to demonstrate the potential of TEC cooling technology and the software backing it up, and also to demonstrate some of the use cases on the Intel platform. And even if you do have some particular use case where you just want those crazy frequency numbers to play games and show off to your friends, there are still many AAA games that just won't really benefit from this. So we saw very little performance uptick in F1 2020. We saw in Shadow of the Tomb Raider that actually the AAA title in that scenario will demand more power from the CPU than the 125 watt limit that you're probably going to want to stick roughly around for the long duration power. So yeah, still plenty of quirks. Let's be honest, the Cooler Master ML360 Sub-Zero is more of a novelty item than something that a real user should actually consider buying. That's especially true with the ludicrous £340 price tag, the poor compatibility, the not silent noise levels to say the least, and the fact that power draw is pretty insane for a CPU cooler and adds as much as perhaps another graphics card worth of power onto your system. So yeah, a pretty unique setup from the ML360 Sub-Zero. It was bizarre to see sub-ambient temperatures, even 0 degrees Celsius readings in just normal conditions with a normal all-in-one cooler. But that's what we get. There's no way I'd even consider buying this or recommending this. Cool piece of technology, but hopefully what we've shown you is enough to scratch your urge to test something like this. I've been Luke Hill for Kick-Guru. Thank you for watching our video review of the ML360 Sub-Zero. Let us know what you think in the comments section down below. Do you think TEC cooling technology has a viable future for enthusiasts? Or do you think the logic of taking a heavily overclocked 10-core chip and limiting it to sub 100 watts or a couple of cores worth of high frequency workload is just bizarre? Let us know in the comments section down below. If you like this video, give us a like and subscribe, do all that YouTube stuff. You can join our channel on YouTube if you want to support us that way. Check out Patreon, Discord, keep in touch with us that way. Buy a cool t-shirt like this one and catch you in the next one.